The next presentation, second last one this afternoon or this evening, wherever you're at, is by Kushan de Silva from Monash University, entitled Prognostic Markers of Diabetes-Associated Mortality in Clinical Notes, a retrospective cohort analysis using machine learning and unstructured big data. Kushan.
Thank you very much. I'm Kushan de Silva, a PhD student from Monash University. Welcome to this presentation titled Prognostic Markers of Diabetes-Associated Mortality in Clinical Notes, a retrospective cohort analysis using machine learning and unstructured big data. The objective of this study was to assess the prognostic ability of the clinical notes and to identify prognostic textual markers associated with 1-year all-cause mortality among people with diabetes following critical care. The flow diagram shows the analytic strategy that we employed. Medical information marked for intensive care, popularly known by the acronym MIMIC, is a relational database. It contains de-identified health data of over 60,000 people. There are different types of data in this database, but we only use clinical text for this modeling study. Being a relational database, data engineering and data pre-processing with MIMIC is an involved complex task. So we had to use SQL commands, and data engineering processes took a little bit of time. We extracted clinical notes written by physicians and nurses. Patient cohort included people with type 1 and type 2 diabetes both as per ICD-9 classification, and the age range spanned 15 to 89. Patients in the database are top coded at 89, which means like there could have been patients older than 89 but still coded as 89. We applied natural language processing methods on the 3 refined cohorts containing physician notes, nurses, and then combined together. Then we applied lasso regularized logistic machine learning models on the training set, and then we assessed the predictive performance on the test data. Predictive performance metrics were calculated, and predictive tokens were elucidated and interpreted. This slide summarizes the results in a nutshell. As shown by the ROC curves, all 3 cohorts performed pretty well. Physician notes in particular achieved near perfect discriminant ability with an area under ROC curve of 99.6%. The 3 horizontal bar graphs show the 50 most predictive tokens from the 3 cohorts. Blue bars show the 25 tokens, increasing the probability of mortality the most, while the red bars show the 25 tokens, decreasing the probability of mortality the most. Here I have given further details about the prognostic ability metrics and the 3 conclusion matrices corresponding to the 3 cohorts. So in conclusion, clinical text revealed to be a strong and novel prognostic marker with possibility to develop scalable applications to enhance diabetes care. Future research on specific diabetes phenotypes and different timeframes are warranted. More information is available in the paper we published in Computational Biology and Medicine. I've given the reference here, and I can be contacted via email given at the bottom of the slide. Thank you.
Thank you very much. If you'll drop your slide set down now, that'd be great. I think one of the issues that comes up in the atmosphere of diabetes precision medicine is the whole issue of coding in medical records. And I think this is really a limitation to the types of studies you're doing. So how can you assure the accuracy of the coding that's in the medical record? I think your study is very affirmative about nurses' notes and physicians' notes, you know, predicting mortality, but nevertheless, the coding and how we're going to get around those kinds of problems.
Yeah, definitely. So it was a concern even in this particular case because this at Mimic 3, at the time it was Mimic 3, but they recently upgraded it to Mimic 4. So the coding was ICD-9 classification, and I mean, there are a lot of studies reporting on the ambiguity of coding, so we can't actually refine the diabetes phenotypes quite accurately. So it was a concern, and that's actually why we included both type 1 and type 2 diabetes people with type 1 and type 2, but in the updated version, Mimic 4, I think it's ICD-10, it's a bit better, but it's definitely a concern. Yeah.
And there's another question relates to, are there is there a particular reason to choose lasso over other variable selection methods?
Lasso has merits like easy interpretability because it shrinks a lot of features and then gives us output the most important ones. And the interpretability is also important from a health informatics perspective. Otherwise, we could have used a deep learning model, but deep learning models are like quite black box. I mean, it's also improving, but and then the interpretability will be questionable. So in this case, it performed well, plus it also gives some interpretable outputs as predictive words.
All right, Kushan, thank you very much. We're now